Hello viewers, I am Dr. Neha Singh from ABES Engineering College, and today we are going to discuss an important topic from the subject polymer, that is elastomer. Elastomers are polymers having the property of elasticity. These are popularly used in industry, and the few popular polymers that we will discuss today are Buna S, Buna N, neoprene, and polyisoprene, which is also known as raw rubber. Now, first we'll discuss about Buna S. Buna S is also known as styrene butadiene rubber, because the monomeric units include butadiene, that you can see the molecule over here, and styrene, which is the molecule over here. They both are taken in the ratio of 75 is to 25, that is 3 is to 1, and an emulsion system is taken, and the initiator molecule is peroxide. That means the reaction is addition polymerization. These two molecules just add to give together the a polymer chain known as Buna S. The polymerization occurs both in cold and hot conditions. If this kind of a process occurs in the cold condition, we call it as a cold rubber. The properties of Bunas include they have high load bearing capacity, they have high abrasion resistance, they have high tensile strength. They are also resistant to weathering, and but they have poor resistance towards the oil and solvents. Their applications include cable coating, industrial hoses, soles, and the latex. That means the liquid form of the polymer is used to manufacture of gloves and coated fabrics. They are also used in making tubings for transportation of gases and oils, and they're also used in manufacturing of sponges, conveyor belts, lining of vessels, etc. Coming on to our next elastomer, which is also popular in industry, is Buna N. It is similar to Buna S because one monomer is common, that is the butadiene. But instead of polystyrene, here we are taking acrylonitrile. So instead of benzene, you can see both the molecules. This is butadiene and this is acrylonitrile. This is similar to polystyrene, though instead of the benzene ring, we have a cyanide group over here. So as similar to Bunas, here the ratio is same, 3 is to 1, that is 75 is 25. And it is all synthesized by an emulsion polymerization where the initiator molecule is peroxide. So the polymerization reaction is the addition polymerization. So that means these two monomers just add to give this polymer chain, which have properties of rubber, which we will discuss. So the presence of cyanide group makes the polymer more resistant towards alkalis. It has a good tensile strength and has resistant to abrasion. It is also resistant to heat, sunlight, and mineral acids. It also shows resistance towards oxidation, though it has poor properties than raw rubber. Now, the applications involve oil resistance in the manufacture of conveyor belts and vessels, and in manufacturing of gaskets, printing rollers. They're also used as adhesives and used in the making of automobile parts. The third and one of the most popular elastomer polymer is known as neoprene. It is popular because it is a uh, synthetic analog of raw rubber, natural rubber, which we obtain from the nature. So it is inspired from that rubber. It is also known as GRM or grade M, and its monomeric unit is chloroprene. It is also known as polychloroprene because of that, and it's commercially also known as duprene. So here you can see the process of polymerization is same, but here instead of two monomers, only single monomer is present, that is chloroprene. It occurs in the emulsion polymerization system in the presence of peroxide initiator, bringing about addition polymerization, where all these chloroprene units just add to give a neoprene molecule. The properties involved that it has a resistance towards oil, it is more durable than raw rubber, it resists temperature considerably well, and resists weathering and ozone degradation too. Their applications used include they are used in cable coating, industrial hoses, shoe soles. Its latex is used for manufacturing of gloves and coated fabrics. They are also used in making tubings for transportation of gases and oils, and in the preparation of conveyor belts and lining of the vessels. Now we come to the raw rubber, which is also known as polyisoprene. This is the only rubber which is used from the which is obtained from the nature. So it is naturally found in a tree called rubber plant that we have commonly seen around household. Its botanical name is Hevia brasiliensis. It is a white liquid in spark known as latex, which contains monomeric units of raw rubber isoprene. So, if you are aware of it, I will also tell you again. So, what happens here? The rubber plant has thick barks. You can see like that. So, what farmers do, they make a cut over here on its bark and they put a bucket below it. So, the white liquid, which is known as latex, it starts collecting into this bucket. And when these buckets fill, they are collected in another big container. So, when all the collection is made, the big container containing the isoprene is added with formic acid. Formic acid initiates this reaction where these latex, that is, these white solvent having isoprene, it polymerizes, it breaks the two bonds and they polymerizes the isoprene, bringing about the polyisoprene or the raw rubber. So, this is how the raw rubber is obtained and utilized, taken from the nature. But there is one catch over here. It cannot be used as such because its properties are very poor. It has poor elasticity. That means if you will pull it more, it will deform. It will not come to its original place, which is an anti-elastic property. It cannot be used as rubber in that place. Tackiness. Tackiness means it has a kind of a texture which will stick in your hands. It gets sticky, like you would have observed when a rubber band it gets old, it gets sticky in your hand. So that property is known as tackiness. So raw rubber initially has the tackiness or the stickiness in this and it also swells in the presence of organic solvents. It has poor tensile strength, poor temperature resistance, and poor water resistance. In this way we cannot use it or draw it into something useful. So what we do, we take it to the another step known as vulcanization. What we do in vulcanization is we add sulfur to polyisoprene structure. So polyisoprene is normally, if you can see over here, is a linear shaped structure, right? So what we do, we turn it into a cross-linked structure which improves its properties. So what we do, we take many units of our polyisoprene, many chains of polyisoprene, I can say 1, 2, and 3 chains we have shown over here, and we'll heat it with sulfur. So what sulfur will do, it will break this double bond, and instead of this double bond there will be the addition of sulfur. You can see one chain is over here and one chain is over here, so both these valencies are being attached with the sulfur, bringing about a cross-linked structure. I want to show you if you want to see it again properly. So this is how it looks like. Suppose here this carbon double bond, carbon is here, and this carbon double bond, carbon is here, CH3 is attached over here, and this is H. Similar, there is a chain over here having CH3 and C double bond C, right? So what sulfur will do, it will break this bond, the single bond it will break. And here the sulfur will be attached in a given fashion like this. So if you can, we'll make a carbon over here again. So the sulfur will represent with the blue color. So it will be attached like this, sulfur and sulfur, sulfur and sulfur. Here also sulfur will be added. Here also the sulfur will be added. So entire structure will become a cross-linked structure when we do the vulcanization process. And when the structure becomes cross-linked from linear, all the properties which were poor side will shift on the higher side. So the improved elasticity will be there, tackiness will be removed, resistance towards organic solvents will be there, tensile strength will be improved, temperature resistance will be improved, and water resistance will be improved. Applications of raw rubber include producing the tires. This is the most important application that is taking place as a long, long time. Tires are produced from raw rubber. They're also used in the conveyor and transmission belts. They're also used for their sealing properties in automotive and industrial applications. They also serve as cushioning material in vehicles and machinery to reduce the vibrations. So, as a shock absorber, it is popularly used. and also forms a key component in the rubber based adhesive for the bonding of the materials. So this was all about the popular elastomers used in the industry. These are some reference books where we will find the description of these elastomeric polymers elaboratively. Thank you for being a nice audience.